Hi guys, welcome to another video. So in today's video I wanted to talk to you about something called cap theorem, which you might have heard before, you might have even studied it in school. And really this is a part of series on distributed systems where we go through concepts such as vector clocks and time and service discovery and microservices, right? Now, cap theorem is a very important concept, and it is important for distributed data stores. So it is a model which basically states that it is impossible for a distributed data store, right, to simultaneously provide more than 2 out of the following 3 guarantees: consistency, availability, and partition tolerance. Right? So the concept is really simple. You have those 3 things, 3 guarantees a data store might be able to provide, but you only can get at most 2. Right? Now, it is a simplified model, right? Different databases have different things, but what really is important here is if you want all 3, there's no way you can get it, right? Now, there's a bit of caveat here on what they are, and really it's been used as a kind of categorization of databases, which is, in my opinion, massively kind of misguided, really. So let's go through those 3 things, right? So consistency means that every read receives the most recent write or an error, right? Now, availability, so every request receives an error response, right? Without necessarily guaranteeing that is the most recent write. So that's a guarantee, right? That every request receives a response. Partition tolerance means that the system continues to operate despite messaging being lost in between or delayed, right, between nodes. Right, so I'll let you settle a bit. Now let's go to kind of how database can fail, how distributed database can fail. So typical failures, there's kind of 2 really. You give a node failure or a network partition. A node failure refers to temporary permanent failure, like or process or hardware. Something is broken. It's a bug in the software. It's bug in some processes. Your process might have killed. It's out of memory. Hardware might have died. There's something wrong with the node. It's not operating properly, right? Those things can typically be fixed on the node. And network partition is something wrong in the link, right? So if you have 2 machines, like at the right schema here, something wrong in between. A router might be bust, right? A network cable must be literally cut, somewhat cut, the network, right? And then basically what it means is those 2 machines cannot talk to each other. There's no way they can talk to each other. Right, so this is network partition. And the cap theorem partition tolerance is, if you go back again, the system still continues to operate despite this network partitions, right? So what does it mean? What does it mean for the theorem? Let's kind of go through, right? And I stole quite a bit of those schemas, so but they're really nice. They really explain things clearly. You have partition tolerance, right? Partition tolerance, and bottom here will have 2 nodes, N1 and N2. They cannot talk to each other. They still continue to operate. They're fine. Availability meaning if I read or write to either or N1 or N2, they give me response, non-error response, right? And consistency meaning if I write X in N1 and I can read X from N2. Okay, so typically in distributed systems you'd have to cope with partitions, network partitions. So typically you don't want to give away partition tolerance. So what does it leave us? Well, in cap theorem, we'll have to choose between consistency and availability, or sometimes called AP and CP systems, right? Consistent partition tolerant and available partition tolerant. Now there is a bit of misconception around what does it really mean. It's not a classification of databases, it's oversimplified. This is true, but it boils down to this choice. If network partition happens, obviously if there's no network partition, you typically can get consistent and strongly consistent and available system, right? But then network partition happens, then you have to give one away, right? Again, network partitions are rare, okay? Like, it doesn't happen every day necessarily, right? If it does, you have a bad network in your data center, things like this, right? So when network partition happens, you have to choose between perfect consistency or perfect availability. And the perfect is really keyword here, which a lot of people do not really comprehend. So perfect consistency is all nodes see the same data at the same time, right? If there's a network partition, nodes cannot talk to each other, there's no way they can write to all nodes, right? They cannot write to all nodes. So, right. And then perfect availability is every request gets a response on success or failure. Every request. So if we have a network partition of two nodes, two database nodes, you write to one, you have to choose whether you accept the write and it's all good, meaning the write, let's say we wrote N1, but there's no network in between, so N2 will never get this write, right? So we're giving away perfect consistency, or we don't let it write. Say, oh, we have a network partition, we cannot achieve this write now. That will happen. Then you're choosing perfect consistency over perfect availability. I hope this helped. Please do let me know in comments, and I also will link some of additional material in the description on the video. So thanks, and do let me know. Please do like this video, do subscribe and get notifications of my new videos, and let me know if you're interested in more topics and which ones. Thanks.